Welcome to This Explainer. Today, we're diving into exactly how ancient civilizations managed to achieve the totally impossible. And we're not just talking about brute force or endless, backbreaking labor here. No, we're talking about brilliant, elegant physics and some seriously advanced engineering.
So let's just jump right in and ask the ultimate question. When we look at monumental structures, like the Great Pyramids or those sprawling Roman aqueducts, our modern brains immediately start to wonder, how on earth did they build them using only primitive tools? Seriously, there were no diesel cranes, no computerized logistics, no hydraulic lifts. So how exactly did they pull it off?
Section 1. Masters of Ancient Physics, featuring the Pyramid Friction Hack. We're going to start our journey right in ancient Egypt, where the whole story shifts away from hard labor directly into highly intelligent science.
For decades, historians literally scratched their heads over how the Egyptians moved these massive, multi-ton limestone blocks across miles of scorching desert. But today, modern scientific consensus, which is actually backed up by rigorous lab experiments from places like the University of Amsterdam, confirms they used giant sledges to transport the stone. Now, pulling a heavy sledge over loose desert sand sounds like an absolute nightmare, right?
Well, here is the crucial point, and it's a completely brilliant ancient hack. You see, when sand is dry, it just piles up right in front of a moving sledge, creating this huge physical wedge that completely stops momentum. You would exhaust your entire workforce just fighting the sand itself. But if you add exactly 5% moisture to that sand, boom! Everything changes. It instantly turns into a smooth, compact gliding surface.
And this 50% figure really illustrates the impact of that moisture. By just wetting the sand right in front of the sledge, they effectively cut the friction of dragging it in half. A staggering 50% reduction. That essentially means you only need half the workforce to move the exact same massive stone. I mean, if that's not the ultimate definition of smart work over hard work, I don't know what is.
Now, what's super interesting here is the actual physics going on behind the scenes. Adding that tiny, specific amount of water creates what physicists call capillary bridges. Basically, these are microscopic water droplets that physically bind the individual sand grains together. It acts just like a temporary glue, magically turning that loose, shifting ground into a stiff, almost concrete-like track for the sledge to just glide right over.
And we know this wasn't just some myth or a lucky guess by modern scientists, because the evidence was literally staring at us the whole time. If you look at ancient wall paintings in the tomb of Jehuti-Hotep, they clearly show a worker standing right on the front of a sledge pouring liquid directly onto the sand. For the longest time, archaeologists just assumed this was some kind of religious purification ritual. But nope, we now know it was a highly practical, absolutely necessary engineering step.
Moving on to Section 2. Lifting the limestone, an unsolved puzzle. Now let's see how this horizontal success builds into the next massive challenge, getting those giant blocks high up into the air.
While the physics of getting the stones to the pyramid is largely solved, the actual vertical lifting is still this fascinating historical debate. I mean, how do you lift a stone hundreds of feet straight up? Leading theories point to three main possibilities. Massive straight ramps, though, to be honest, those would require an absurd amount of extra material, spiral or wraparound ramps built directly into the structure, or an ingenious system of simple yet highly efficient wooden levers that would kind of walk the stones up step by step. Whichever method it was, it required some truly staggering mechanical genius.
All right, Section 3, Rome's Invisible Water Network, the engineering of gravity. Shifting our focus over to the Roman Empire, we encounter another monumental leap in ancient engineering. This isn't just about lifting heavy blocks anymore. This is about achieving absolute precision on a continental scale.
So, when most people imagine Roman aqueducts, they immediately picture those iconic, towering, arched stone bridges spanning across these deep, beautiful valleys. It is a stunning image, for sure, but is that really the whole story of how Rome managed its water?
Surprisingly, no. About 90% of these vast water systems were actually entirely hidden underground. You have to remember, the Romans didn't have mechanical pumps to force water over hills. Instead, they relied purely on the physics of gravity to push water forward across massive, massive distances, often tunneling right through solid mountains. To transport that water over 50 miles without a single pump, they had to maintain a flawless, constant gradient. Think about this. Sometimes they engineered a drop of as little as 1 single foot for every 1,000 feet of length.
If the slope was too steep, the rushing water would just destroy the walls, but if it was too shallow, the water would just sit there and stagnate. Just 1 foot of drop per 1,000 feet. It's incredible.
So how on earth did they do it? Well, they mapped out this impossible precision using some highly specialized tools. The groma was used for drawing perfectly straight lines and right angles. The dioptra let them level and measure specific angles. And then there was the corbates, which, believe it or not, was essentially a giant 20-foot-long wooden spirit level that used plumb lines to guarantee that perfectly slight downward slope. It was painstaking, millimeter-perfect work, and they did the whole shebang entirely by hand. Section 4. Concrete that heals itself, the secret Roman ingredient. Now, perfect angles alone don't explain why these structures are still standing today, 2 millennia later. For that, we need to look closely at the actual chemistry of their building materials.
The real Roman secret ingredient was a material called pozzolana. This was this totally unique concrete mix that combined volcanic ash, lime, and aggregate. And what is just absolutely astonishing about this recipe is that it actually gets stronger over time. When water enters microscopic cracks in the Roman concrete, it triggers chemical reactions with the lime and the volcanic ash that literally self-heal and seal the crack right up. They essentially engineered a building material that repairs itself. No way, right?
It's honestly incredible, and quite frankly a little humbling, to think that while our modern infrastructure, our bridges, highways, and buildings, often begin crumbling and needing major repairs after just a few decades, these ancient marvels were chemically designed to endure for millennia. They weren't just building for their own lifetime, they were literally building for eternity.
Which brings us to the ultimate question I want to leave you with today. We've seen how a simple 5% moisture trick can move mountains of limestone, and how volcanic ash can create self-healing structures that outlast entire empires. So, considering these phenomenal feats of physics and chemistry, could the key to building our sustainable, long-lasting future actually be buried right there in our ancient past? Thank you so much for exploring this explainer with me today, and I challenge you to look around at our modern world and wonder, what ancient hacks might we still be overlooking?